Hello everyone and welcome to Unit 5. We're in the Quadratic Functions unit and it's going to be a good unit. I'm excited for it. We're going to skip page 2 for right now and go right into page 3. Page 2 will be a warm-up for next class. So we're going to be looking with quadratics is all about factoring, understanding the roots. We've done a lot of this already, so I'm expecting you guys to remember this. I'm going to go over it very quickly, and then I'm going to get into the more difficult things. So if you need to go back to your Unit 3 notes or 4 notes and review, you're more than welcome to. So just know that's why I'm going to be moving fast. So the first way to factor GCF, you've done this since probably 6th or 7th grade. Take out a GCF and put parentheses around what the factor is. Type 2 factoring is the difference of two perfect squares. So you have a perfect square as a first term, perfect square as a second term. Only can do this when you have subtraction, and you can write them as, we call it, difference of two perfect squares. The third way is factoring, the way that I like to say, factors of C that add to B, or factors of C that subtract, if it's a subtraction sign, to B. And we do that only when it's A equals 1. So real quick, and again, if you need to work on this, please come see me. In this case, you'll notice that we have 9m cubed, 3m squared, so I know my GCF is a 3m squared. Take that out. I would divide each by 3m squared if you remember that's what we're trying to do with the GCF. And therefore, we're left with 3m minus 1. Notice that the inside of the factor is 3m minus 1. We know we can't do anything with it. We are done. Notice that we have two terms. Therefore, and you see a subtraction sign. When you see two terms, you look for a GCF first. There isn't one. We have a variable and a number. So therefore, we know it's immediately difference of two perfect squares. What times what gives you y squared, y, and y. And then what times what gives you 16, positive 4, negative 4. You're done. Same thing with C. Two terms, no GCF. Subtraction, we know it's 2x and 2x. 525 goes to 5 and 5. D and E is trinomials, and therefore we know it's not two terms, we know it's three terms, so factors of 40. If you have to, write them out. Factors of 40, 20, 410. And you realize that none of those are there yet until you get to 8, 5. Factors of 40 that add to negative 13, 8 and 5. X minus 8, x minus 5, you're good to go. Factors of 90 that subtract to positive 1, 9 and 10. So m plus 10, m minus 9. 10 times negative 9 is negative 90. 10 minus 9 gives you positive 1. That's how we would do that. The fourth way that you're going to learn how to factor, which is a one way you do not know how to do, is type 4 factoring, which is when the a value, right here, the a value is greater than 1. When you do this, you're going to take 2 times 12. You do a times c, product of 24. So the factors of 24, 124, 212, 3, 8, and 4, 6. Which one of those adds to 11? So the only thing that you're changing here is the 2 and the 12 gives you 24. That's your new, quote, C value. It doesn't actually change for the problem, just for this one. So 3 and 8, where did that 3 go? There it is, 3 and 8. We then are going to split it off. So I usually write it like this. Then I split off. So the 2x squared stays the same. Notice that stays the same. The 12, why is this not working? 12, there we go. And the 12 stays the same. So 12, 12. The only thing that changes is the 11, the middle term. So you put parentheses around those. You then factor GCF out. 2x factors out from the first one. 3 factors out from the second one. You then notice that the insides are the same. You write those down. You write 2x plus 3 down as the other factor. So let me repeat that again. After you've GCF'd from here, this step, you write down the factor that is the same on the inside as one of them, the number that you the GCF that you factored out becomes the second factor right there. So let me show you what that means when we practice. So we're going to take 2 times 2 gives you 4. Factors of 4. 2 and 2. 1 and 4. Which one adds to 5? Well, clearly the 1 and 4 adds to 5. So what I'm writing it out is 2n squared plus 1n. That's where the 1 comes into play. Parentheses around it. Plus 4n plus 2, parentheses around it. So the only thing I changed was the 5 turns into a 1n and a 4n. The 2n squared stayed there. The 2 stayed there. The only thing I changed was that 5n. I then factor a GCF out. My GCF out of this one is going to be an n, and the GCF out of this one is a 2. So I'm going to factor an n out, and I'm left with 2n plus 1. And I factor a 2 out here, I'm left with 2n plus 1. How do I know that I did it correctly? I have 2n plus 1, 2n plus 1. I then write out my 2 new factors as n plus 2 and 2n plus 1. And that is my answer. Let's try it on this one and then stop, rewind if you don't understand that, or come and see me for help. Notice that the a value is greater than 1. Notice that I cannot factor a 4 out of a 15 or 25, so therefore I have to go into this type 4 factoring, which is a greater than 1. 4 times 25 equals 100. So I'm going to write out my factors of 100. 100, 250, 425, 5 and 20. And right there I realize I'm looking for factors of 100 that subtract to give me 15. Well, there it is. So what I'm going to do is I'm going to split up the negative 15 into, using this, I'm going to keep the 4n squared the same and the minus 25 the same. So I'm going to split this up into negative 20n plus 5n. I know that it's got to be negative 20 because this is a negative 15 I'm trying to get to. So negative 20n plus 5n. I then put parentheses around it. And I'm going to do a GCF. Factor out a 4n. n minus 5 is what I would get for factoring a 4n out. I see that a 5 is in common, not an n but a 5, so plus 5, parentheses, n minus 5. I know that I did it correctly because the n minus 5 is here. So I'm going to get 4n plus 5. That's where I get it from these two. And then from n minus 5 and n minus 5, I get n minus 5 there. And so that is completely factored for both of those problems. If you struggled with that, rewind it, watch again. If you're still struggling, move on. See if what I do in the next few pages works. If it doesn't, please come see me for help. So completely factored.
Yeah.
I'm going to do A and B, and you're going to do C and D. So just looking at this, completely factoring usually means step 1 is GCF.
Oh.
And this is my son Seth. And
Yeah.
2 is either trinomial factoring or difference of two perfect squares.
Oh.
So you always have to do that. Here you go, Seth. Say hi. There you go. So you always look for a GCF first. So in A, you notice that we have a 4, a 12, and a 40. So I'm going to GCF a 4 out first. X squared plus 3x minus 10. Notice it's a trinomial. So therefore it must be factors of 10 that subtract to 3. X plus 5, x minus 2. 5 and negative 2 give you negative 10. 5 minus 2 gives you positive 3. That's the answer. Done. For B, you will see it's only 2 terms. Always look for a GCF first. 6, x squared minus 4. And then you're going to get x, 2 terms, difference of two perfect squares, x plus 2, x minus 2. pause the video and do C and D, please. We'll look at it in class. Pause it. The next part, we're looking at solving quadratic equations. We've done this before. This should be nothing new. When you have two factors, you set each factor equal to 0. This was already factored for you. And you get x equals -7, x equals 3. Same thing here. Notice the 4 does not matter. You're only setting the factors equal to 0. There is no x here. So 3x plus 2 equals 0. 4x minus 3 equals 0. You can do this out -2/3 and 3/4. So nothing new there. So when we look at 3 through 6, you're going to notice that you have quadratics set equal to some other terms. When you see a quadratic set equal to other terms, you must, let me repeat that, you must set it equal to 0. Now I'm going to start with, we're going to do 4, 5, and 6, and you guys are going to finish with 3. So here's 4. You see quadratics set equal to 0. What I would like you to do is always allow the x squared to be positive. So if I subtract the 3x squared to this side, I'm going to get -2x squared. So I'm going to move all terms to the other side, allowing me to get it set equal to 0. So 3x squared minus x squared, 2x squared plus 9x minus 5 equals 0.
Hello.
So 2x squared plus 9x minus 5 equals 0. You sit there and you say, well, I can't factor that. Well, we have to go back to the method that we just learned. That's why I want to do 4, 5, and 6. 2 is bigger than 1, so I got to do this idea of 2 times 5. So I'm looking at factors of 10. 1 and 10, 2 and 5. I need factors of 10 that subtract to give me 9, because that's the middle term, 9, 1, and 10. So I'm going to rewrite it as 2x squared plus 10x minus 1x minus 5 equals 0. And so now I need a GCF. The GCF of 2x squared and 10x is 2x. I'm left with x plus 5. Notice here, and this is where it changes for you guys, see how they're both negative? I need it to be x plus 5 in the parentheses. Here I'm left with -1x minus 5, so I need to take a -1 out. When I take a -1 or factor -1 out, I'm left with x plus 5. And therefore now I have 2x minus 1, that's what the two outside ones are, and the factor of what's inside the parentheses of x plus 5 equals 0. At this moment, now that we have both factors that equal 0, I can now say 2x minus 1 equals 0, x plus 5 equals 0, and I get x equals 1/2, and x to equal -5. I don't need to check this because there is no radical, and so you can always check in your calculator, but you don't need to. Notice with this one I'm going to add 3, so I have 6b squared minus 13b plus 6 equals 0. There's nothing I can take out of all three terms that are the same, so therefore I need to do the a greater than 1 method of factoring, which I now have 36, as 6 times 6 gives me 36. So 136, 218, 313, 4, 9. Oh, I need factors of 36 that add to 13, 4, and 9. So 6b squared minus 9b minus 4b plus 6 equals 0. Parentheses around it. What can I take out? I can take out a 3b, get 2b minus 3. Take out, look at this, I need 2b minus 3. What do I need to take out? I need to take out a negative 2b there. So negative 2b allows me to get the inside of 2b minus 3. And now I rewrite it with the factors. 3b minus 2. b minus 3 equals 0. Set each factor equal to 0. And I'm going to get b to equal 2/3, b to equal 3. So, what I would like you guys to do right now is finish 3 and 6. We will, in class, look this over and finish the next page along with the very first page. So welcome to day 1 of Unit 5. Good luck, and I will see you next